So let's continue our discussion of how variables can be passed into functions. But this time we're going to take a look at what happens when we use a pointer. Now this is still going to be an example of pass by value, but we're going to have a little bit more flexibility in the things we can do. So taking a look at our code, what happens? So I have my function and I have my main. Notice the function is a little bit different because the argument is now a pointer. Note though that doesn't mean the argument isn't passed by value. It just means that my input to this function, right, the parameter here, is going to be a integer pointer whose address is passed by value. Okay, it's not going to be what is called a pass by reference. There's also another thing you may have heard of if you're in a language like C++. They use slightly different syntax, which is pass by reference. And we're not quite doing pass by reference here. We're using a pointer under pass by value. Okay, so take a look at our main. First thing I have here is my declaration of a variable. So what I'm actually going to do here is I'm going to create an int pointer. So I'm going to create a new variable and allocate memory for it in order to store an integer. We'll end up seeing, this code is actually kind of complicated. We'll see later a little simpler way to write this stuff. And over here we have, right, if I want to say something like, oh, set that I equal to 15, I got to do star I equal 15, and then I can call my function. In this case, right, a new stack frame gets created, and then what happens is that the address, right, of this I, right, the address that malloc returns, that address is now going to go over here, right? So that stack frame contains that address, or a copy of that address. All right, so inside this function, imagine this function is running, what's going to happen? Okay, I do printf star n, well, star is a dereference, so basically that I variable, I'm going to look inside and see that 15. So I'll print out a 15 over here, because I've just looked inside of it. All right, so now what if I do something like star n equal 30? Well, this is then going to that bit of memory I allocated and saying equal to 30. So if I go and I do my print star n, well, I'll get my 30 back out. Okay, last line here, n equals 0. So this line, it'll compile fine. There won't be any bugs or anything. But the issue is that this line is basically changing the address that I have. So if I want to go and later do something like star n after this line, I'll get an error because I am literally saying the address where this thing is stored is now address 0. I'm changing the address, right? I'm changing the copy of the address that I have in this stack frame. So this is, well, here it doesn't give us any trouble, but we just have to keep in mind that we're changing something different, right? Star n is the variable outside, and n is the variable inside of this function. So there's two different things here. All right, so that runs. We've kind of traced from here down to here, and now we do printf on I. So we go and do star I. Well, star I in this case is actually going to print out the 30. The reason being is that star I basically is the piece of data that I was pointing at. So I was pointing initially at 15, and when we passed that pointer to function, well, then all of a sudden function had a reference to that data. And so when we do that equals 30 over here, when we do this line, we're basically going to that original data that was defined by the malloc and updating it. And so that I is no longer 15, it's now 30. Because we did this, because we have this kind of pointer usage, right? We passed not just the original data, but we passed a pointer to it. And so now I'm allowed to change it in the outside world, right? Func had an effect on the contents of main. In the last example we did with pass by value, that wasn't the case because we made a copy of the variable, and so anything we did inside would just stay there. But because we're passing a pointer, right, it's the address that's passed by value, right? That's passed as a copy. But then when we do a star, basically we're saying, okay, I'm going to go and look at the actual data it's looking at. And then when I change it, well, then it changes for everybody because everybody has that same address. All right, and I can do main again, and I can do I equals 10. So I can update that value, and then if I run function again, you notice that in function I'm going to end up printing out 10 because again my function right is going to look at that same bit of memory that main is changing. Sets it to 30 over here. Does the printf sees 30 again? That's fine. And then if we do a print out on I, right, again we can see the change in func main. So basically we have both main and function are both changing the same piece of data. Last line there is going to be our free because, well, this is a dynamic allocation, and we need to make sure that malloc memory is returned to the system. All right, so a little bit more flexibility using pass by value with a pointer. Let's start cleaning up that code just a little bit. So this is what's going to be referred to, well, we can refer to it as pass by reference. It's passed by reference on a pointer that's passed by value. Just think of this as pass by reference. So here we've cleaned up our syntax a lot. From the previous slide. You'll notice basically what we have here is instead of creating doing a malloc for I, I'm just doing an int I. So I'm doing a stack allocation there right in main. So main stack frame is now going to have a space for I. And then in func actually stays completely the same, but what I'm doing is I'm putting an ampersand in front of I. So the ampersand is going to get me the address of I and send it as an argument, right, a passed by value argument to the function. And then in that case, right, then I can do all my stuff in here and manipulate it however I want. So the key bit is this, right? Instead of doing instead of having to do that malloc allocation, I can just use the ampersand to get the address of that get to the address of that variable, and then pass those different functions. And then I'll get that same behavior where I'm allowed to basically change the outside world from that func, because I'm passing now a reference to that variable instead of a copy of that variable. As a final example here, let's take a look at some string stuff. So in this case, I have my two functions here. I have getString and setString. GetString really doesn't do anything. It just takes in a string and returns it back out. SetString is meant to basically take two strings in and then copy one from the other one. When we see those in the code, we'll walk through them a little bit more in detail. But for now, let's jump down to the main. So main, first line here, is going to declare P, Q, and S. So this first is just a pointer to a character. Then I have Q and S, both are going to be strings, and those are just different ways basically to declare strings, whether I can do the Q brackets or pointer S. So first thing I do is I do a printf on S. Well, that's just printing out a string, so that's going to print me out the word hello, no problem. Then over here I go P equals getString. Well, getString, we're putting in S as an argument, right? So S ends up going over here, and basically S is an address, so copy of the address gets sent to getString. GetString then returns a copy of that address as a return value. And that return value, right, is what's going to be set into P over here. So we basically, right, S is some address, and we just copy it, once as an argument and then once as a return value, and it gets stored into P. Still the same address, so then when we do a print on that, it'll end up printing hello, because it's still the address of where does hello begin in memory. So you've executed up to there. Now we do setString on Q and P. So in this case, we're calling this one over here. We're basically filling in my Q over here, my P over here, and I'm doing a copy between them. So in this case, right, I'm using the string libraries function to copy a string, and which is basically going to go and look at one of these. It's going to look at string 2, look at the first element in there, and then copy it into the first space of the second argument, the second string. And it'll keep on looping until it gets to the end of that string that's copying over. And it's copying from here to here. Then when we go to display that out, we see the word hello has been copied over. A couple of notes here. First of all, the only reason that copy really works is because morning is larger than hello. Remember that there's only going to be a certain amount of memory, right? Both Q and S are going to be allocated in the stack for the stack frame for main. We don't want to run out of our bounds. So we're copying basically a smaller string into a larger string, so everything's going to be fine. The second thing is that if we weren't passing around addresses, this wouldn't work. So if I had something like maybe, I had something like set integer. You can maybe imagine, right, this is set integer, int1, int2, and then over here I have maybe int1 equal int2. If we had a function like that, it would not work. Because what happens is we're changing that. We'd still set basically int1 equal int2, but that change, that copy only happens within that function, only happens within that set integer function. It doesn't get seen by the outside world. Now, in our code, everything is fine because we're passing around pointers. And so pointers means that basically everybody gets to talk about the same piece of memory. So everybody can go and change the same piece of memory and see the changes that everybody else has done as well.